find formulae for cos 3 theta and sine 3 theta in terms of sine theta and cos theta. So we might need powers of sine theta and cos theta, but what it means is we're not going to have a multiple of theta in the answer, so we will only have just thetas, no 2 thetas, no 3 thetas or anything else, just thetas, and then we might raise them to powers, or we definitely will. Okay, so this is another application of de Moivre's theorem, and if we think about it, if we had cos theta plus I sine theta, if we take that number and cube it, according to de Moivre's theorem, that would give an answer of cos 3 theta plus I sine 3 theta. Okay, that's just de Moivre's theorem. Okay, so all we're going to do is expand that left hand side and then compare it to the right hand side, and we should be able to equate imaginary parts and real parts, and then we should be able to get these expressions, because you can see we want an expression for cos 3 theta, so you can see on the right hand side the real part is cos 3 theta, so if we compare it to the real part on the left hand side, that will be our answer, and the imaginary part on the right hand side is sine 3 theta. We'll compare it to the imaginary part on the left hand side once we have done the expansion. So to expand something to a binomial to the third power, we're going to use Pascal's triangle, so 1 1 1 2 1 1 3 3 1. Okay, so this is going to be cos cubed theta plus 3 and cos squared theta times I sine theta plus another 3, and that would be cos theta times I sine theta squared, cos theta times I sine theta squared, like that, plus the final bit is going to be I sine theta cubed. All of that cubed. So we've got quite a lot of tidying up to do, but we know that that equals cos 3 theta plus I sine 3 theta. Just separate that triangle off. Right. So just going to do a bit of work on this left hand side before I start to group. So cos cubed theta plus, well, this is an imaginary part, so I might just call that 3i cos squared theta sine theta. This next bit is definitely going to need some work, so you have it in the bracket. You've got I sine theta squared, so that's I squared sine theta squared. Well, I squared is minus 1, so I'm going to bring that minus 1 out, so that is going to be minus 3 and cos theta sine squared theta. But note that that now contributes to the real part and not the imaginary part. The last bit here, you've got I cubed sine theta cubed. So the sine theta cubed is easy enough, that's sine cubed theta. I cubed is I squared times I. Well, I squared is minus 1. Minus 1 times 1 is minus I. So that would be minus I sine cubed theta. And we know that equals cos 3 theta plus I sine 3 theta. So now, before we start to compare real and imaginary parts, I'm just going to group the left hand side nicely. So the real component is cos cubed theta, that is real. The second term has an I in it, so that's imaginary. The third term is real, so minus 3 cos theta sine squared theta. That's the real part, plus the imaginary part. Well, you've got 3 cos squared theta sine theta, 3 cos squared theta sine theta, then you've just got minus sine cubed theta. And all of that is, you can take a factor of I out of those. So now we've got the real part on the left, imaginary part on the left, equals cos 3 theta, the real part on the right, plus the imaginary part on the right, I sine 3 theta. So now we've got it exactly where we want it. We can compare the real parts. Comparing real parts, and when I say compare, I mean on the left hand side of the equals sign and the right hand side of the equals sign. Okay, so I'm going to write the right hand side first because the question asks us to find expressions for cos 3 theta and sine 3 theta. So cos 3 theta is exactly what we want. So comparing real parts, cos 3 theta must equal the real part on the left hand side, which is cos cubed theta minus 3 cos theta sine squared theta. Okay, so this is an identity that we can potentially, if you can remember it, you can use it. And now we compare the imaginary parts. Okay, so on the right hand side we have sine 3 theta, exactly what we want, equals on the left hand side 3 cos squared theta sine theta minus sine cubed theta. Again, a really handy application of complex numbers. You've got a nasty trig identity, and we've been able to do this using complex numbers, using de Moivre's theorem. It is really handy, and again, could easily pop up in an exam question, very common.